Hello friends, this video on Chemical Kinetics part 12 is brought to you by examfear.com. No more fear from exam. So as I told, the molecularity of the reaction is nothing but the number of molecules or ions that participate in the rate determining step. That is the smallest step. And there is a link between the molecularity and order of the reaction. We have seen till now that order of the reaction, for example, we told that rate is equal to K e to the power x, b to the power y. Right? For a reaction A plus B gives C plus D. And we told that these were experimental values. And this, the chemists were confused why this is, you can't calculate. So they found that if this is a complex reaction and it will have n number of steps, the smallest step will give you the value of x and y actually. The coefficient of A and B in the smallest step is nothing but x and y. So let's take one example of a reaction. NO2 plus carbon monoxide gives carbon dioxide and NO. So experimentally, this has been seen that rate is equal to K and NO2 to the power 2. Second order equation. This is experimentally, it has been seen that. Now let's try to find this value or find this equation using the concept of molecularity. Now if you see, this is a complex equation or complex reaction. It's two-step. This is a two-step reaction. So in first step, what happens is NO2 will react with another NO2 to forms NO3 and NO. And second step, what will happen is NO3 that is formed will react with carbon monoxide to form carbon dioxide and NO2. Now this is a slow step and this is a fast step. As I told, the slow step is the rate determining step and we're talking about the rate of the reaction. So this reaction 1 will rule. Here if you see, nothing but there are two NO2 molecules. So if you see directly, we can say that rate is nothing but K NO2 to the power 2. Using the concept of molecularity, we found the simple steps for this complex reaction and we found the slowest step and we found that rate is nothing but K into NO2 to the power 2 because there are two NO2 molecules. Correct? So simple rule is for a simple reaction. For example, I have a simple reaction. Let's suppose this is my simple reaction. It gives some product. And then this is a simple reaction. Right? So in that case, my rate will be K A to the power A and B to the power B. So in this case, you do not find the value experimentally. These values only you can use A and B. So here if you see, this complex reaction has so many steps. The slowest step will take because that is the rate determining step, and in that slowest step if you see, the coefficient of NO2 is 2 because there are two NO2 molecules. Correct? So if you see, for the complex reaction, we found the slowest step, right? And the molecularity of the slowest step is nothing but the order of the overall reaction. If you see, the molecularity of the slowest step is 2 because there are two NO2 molecules reacting, and order of the reaction is also 2. Let's take more examples to understand this concept. So NO2NO plus O2 gives 2NO2, and experimentally we have seen that rate is equal to K NO2 to the power 2 O2 to the power 1. This is experimental value. Let's try to prove this value using the molecularity concept. This is again a complex reaction. There are two steps. It is a two-step reaction. In first step, NO will react with oxygen to form NO3. Second step, NO3 will react with again NO to form NO2. This is fast and this is slow. Again, this is experimental value, experimental reactions. Actually, this data, this has been proved experimentally that this is a complex reaction and happens in 2 steps. Again, this is my slow reaction. So for this, I can just say the rate has nothing but K into concentration of NO3 into concentration of NO2. But if you see, NO3 is not part of reactant. What should we do? This is the reaction we have taken. So we'll use first equation to find the value of NO3. For the first equation, K dash, let's suppose, is nothing but concentration of NO3 by concentration of NO, concentration of O2. Correct? Equilibrium constant. So concentration of NO3 will be nothing but K dash, concentration of NO, concentration of O2. So I'll put that value here. K into K dash, concentration of NO this is NO. NO3 becomes concentration of NO, O2, NO. K into K dash becomes some other constant, NO square, and that is the experimental value. So it is NO here. Correct. So using molecularity, we can actually find the rate law if we know all the steps for a given reaction. Correct. Let's take one more example for this. So if you see, ozone converts into oxygen. For this, the experimental value is O3 square, rate is equal to K O3 square O2 to the power minus 1. Let's see if we can find this using molecularity concept. Again, this is a complex reaction. There is 2 steps. First step, what happened? O3 will break into O2 and O. Second step, ozone will again combine with this oxygen, we call nascent oxygen, to form 2O2. This is a fast reaction, this is a slow reaction. So we'll take the slow reaction. So with this I can say that rate is nothing but K into concentration of O3, concentration of O. But again, if you see, O is not part of this reaction. O is part of first reaction. So from first reaction I can see that K dash is nothing but concentration of O2, concentration of O, concentration of O3. Correct? So with this I can say that concentration of O is nothing but K dash concentration of O3 by concentration of O2. So let's put this value here. Nothing but K O3 instead of concentration of O, we'll put this K dash concentration of O3 by concentration of O2. And there is nothing but K dash into K is nothing but some other constant K double dash O3 square O2 to the power minus 1. And if you see, that is exactly same as the experimental value. It's very close to experimental value. Correct? So the molecularity and order of the reaction is linked, right? Order of the reaction is generally experimental, and molecularity, you have a reaction, complex reaction, you find the slowest step. For the slowest step, find the molecularity of the reaction. So molecularity of the slowest step of the reaction is nothing but order of the complete reaction. Again, this reaction H2O2, my peroxide, and this forms water and oxygen. For this, the experimental value is K H2O2 into I minus. Let's see. Again, a complex reaction, two step. First step, what will happen? This peroxide will react with I minus to form water and IO minus. This is a slow process. Second step, what will happen? This H2O2 will react with IO minus to form H2O plus I minus plus O2. This is a fast reaction. You need not learn all this reaction. This is just to clear your concepts that the molecularity and order of the reaction are linked. So in these two reactions, if this is slow, we'll take this reaction. We can just say that this rate is nothing but K into concentration of H2O2 and concentration of I minus. And if you see, this is closely matching with the experimental value. Let's compare the molecularity and order of the reaction now, right? When you talk about the order of the reaction, it is the experimental concept. You need to find using experiment. You can actually determine by just looking at the equation or reaction. Molecularity, yes, we can determine by looking at the elementary reaction. Please note, by just looking at the elementary reaction. Even if it is a complex reaction, you need to find all the elementary reaction. Then we need to find the slowest step elementary reaction, and that gives the molecularity of the reaction. Order of the reaction, it is nothing but sum of the powers of of concentration, the rate law. If this is my rate law, then x plus y is my order of reaction, and molecularity is nothing but sum of the stoichiometric coefficient of the reactant, in this case A plus B. Order of the reaction is generally 0, 1, 2, 3, fraction or even negative. Molecularity is always whole number for a given reaction, right? 1, 2 or 3. First order, second order, third order, that's how we call it. And for molecularity, we call unimolecular, bimolecular, trimolecular, like that. Order is applicable to elementary as well as complex reaction. Please note, we can define order for any kind of reaction, but molecularity is applicable only for elementary reaction. And as we have seen that for the complex reaction, we have just seen that for the complex reaction, the order is actually given by the slowest step, generally. Right? And the molecularity of the slowest step is generally same as the order of the overall test. Please note, it is generally, not always. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.